Dear students, I welcome you in Chemistry of Solution. In our standard 12th textbooks of chemistry, chapter number 2 is solutions. There are so many use of solution in our daily life, like spare parts of automobiles made from brass, made from German silver and made from bronze. Some difficult and more qualified properties if we want to increase. Suppose pure iron is easily corrodized, but when we take a solutions as a stainless steel, iron, chromium and nickel have the different property. So in our daily life we use so many solutions. So in this chapter we are studying about the importance, like 3 or 4 questions they will ask in our exams. So we must have to teach and understand this chapter. The first question is, what is solutions? We know that solutions is a homogeneous mixture of 2 or more than 2 components. Solutions means mixture of 2 or more than 2 components. And which type of mixture? You remember, homogeneous mixture. What is meaning of homogeneous mixture? Suppose you take a glass and you add water and also you add some sugar. In this one you make a solution. In these solutions you take a spoon from this area, or you will take a solution by spoon from this area. The homogeneous mixtures means each and every area of solution have the same part of 2 or more than mixtures component. In this our case, each and every part of the mixture, each and every part of the solution you take and taste have the same taste you are feeling. Because in all area they make a homogeneous mixture. You will never see here the part of sugar is more and here the part of sugar is less, because this one is the homogeneous mixture. Now we know that solution is a mixture of 2 or more than components. But in our textbook, in our syllabus, we are studying about the binary solutions. What is the meaning of binary solutions? Only 2 components take part to make in a solution. One is major part, known as a solvent. The another parts, then after major part is small part. May be possible 1, 2 or 3, 4 components fill in a small part. In our syllabus, the major part is known as solvent, while the minor part is known as a solute. So, in our study, only one solvent and only one solute will make a homogeneous mixture and give us a solution. This solution is known as binary solutions. Only two components are present in this solution. One is solvent, another one is solute. So, the type of solution can be depends upon the physical status of solution. If the physical status of solution is gaseous, we know as a gaseous solution. If the physical state of solution is liquid, we know as a liquid solution. If the status of solution, physical status of solution is solid, we know as a solid solutions. So, dear students, only main three type of solutions depends upon the physical state of solutions. After homogeneous mixing of solvent and solution, if our solution is a gaseous state, the type of solution is gaseous. If our solution state is liquid or solid, we know as a liquid solution and solid solution. This one is depend upon purely nature or physical state of solvent. Here we know that gaseous solutions, all solvents are in gaseous form. While you see that if we have a liquid solutions, the solvent are liquid, liquid and liquids. If we have the solid solutions, therefore the state of solvent is also solid, solid and solid. The major part of solvent, the major part of solution is solvent, can determine the type of solutions. But in our gaseous, liquid or solid solutions, we know that the solute are different. Solute may be in gaseous state, solute may be in liquid state, like solute may be in solid state. So another three types of solutions: gas, liquid and solid, gas, liquid and solid, gas and liquid and solids. So afterwards we can classify there are 9 types of solutions: gaseous, gaseous, liquid, gaseous, solid, gaseous, gaseous, gas in liquid, liquid, solid in liquid, while the gas, liquid and solid in also solid solvent. So we can remember there are 9 types of solutions. With example, suppose the major part of solution in a gaseous form, so solution is gaseous, and the minor part is gas, we know as a solute. If in our solution, solute is a gas and solvent is also gas. The example is dioxygen dissolved in nitrogen. In air, air is the most important and common example. For solute is also gas and solvent is also gas. In air, we know that solvent is dinitrogen, while so many gases like dioxygen, carbon dioxide, ch-2 in a vapor form, while the pollutions as a sulfur dioxide, nitrous dioxide, carbon monoxide, all are as a solute form. But in a major part, nearly 80% is dinitrogen. So therefore, this one is also an important example. Similarly, if we have the small part in a liquid form while the major part in a gaseous form, like chloroform dissolved in dinitrogen. Similarly, solute in a liquid, gaseous form, solvent in a gaseous form, major part. There are so many liquids soluble in air. like acetone, like ether, like methanol, if you put them in air, it converted liquid into gaseous and make a homogeneous mixture. Similarly, in the gaseous solution, if the solute, the small part, in a solid form, while the major part in a gaseous form, as an example, camphor in nitrogen gas. Also, the second type of solution is liquid solutions. In liquid solutions, if the solute is gas, liquid and solid, we know that in liquid solution, the major part is in a liquid form. Therefore, solvent in a liquid form, as example, solute in a gas, while the solvent in a liquid, dioxygen and carbon dioxide dissolve in water. We know that in sea water, in our normal tank of water, you know that there are dioxygen as a gas dissolved in water. So the small animals, small part of living organisms will live in a water. Why? Because the part of oxygen which one is necessary for a life, they will use this oxygen which one is dissolved in water. Similarly, soda water is also an example of solute as a gas form, while the solvent in a liquid form. So soda water is also an example for this phenomena. Similarly, liquid and liquid. If solute is liquid and the solvent is also liquid, as for example, ethanol dissolved in H2. Petrol dissolved in kerosene, petrol and diesel and kerosene, we make a homogeneous mixture. They all are solute and solvent in a liquid form. While the third example is if the solute is solid while the solvent is liquid, example is glucose dissolved in water, urea dissolved in water, sodium chloride salt, common salt dissolved in water. All ionic compounds of our laboratory are examples of solid, solute, while the liquid, solvent. So you remember also this one. The third examples of solutions, solid solution. In this solution, this type of solution, if the solute is gas, liquid and solid, but while the common is always solvent is solid, solid and solid. So what happens if our solute is gas while the solvent is solid? Examples, dihydrogen in palladium, ammonia in nickel. So what happens? They absorb, because we know that in palladium, in nickel, here volume of atoms is higher. So some empty space is present between the atoms of palladium, atoms of nickel, while the small part of hydrogen atoms have the small volume. So it can be easily live in empty space. So they make a homogeneous picture. In organic chemistry, in our daily so many reactions in chemistry, mixture of palladium and hydrogen, mixture of hydrogen and nickel, they are also be used as a catalyst due to this property, because they make a homogeneous mixture, hydrogen with palladium, hydrogen with nickel. If our solute is liquid and solvent is solid, amalgam, in amalgam we know that the small part in a liquid form, means mercury. Mercury in a liquid form have the like around this one, and out of this one we know that the big part of sodium, of iron, of zinc, they will make around this one the small particles of sodium, small particles of zinc, small particles of iron. They arrange themselves around the pins of mercury, and it gives us more surface area. Due to this more surface area, the rate of reaction will be increased. So many organic reactions we take as a sodium, zinc, iron as a active part in catalytical process. So this mixture amalgam is also most important. The last example of if our solution in a solid solution, the solute is solid and the solvent is also solid. The mixture example is mixture of copper dissolved in gold. Mixture of copper and gold. We know that pure gold is soft. If we press them, they change the shape. But for hardness, we add some copper with gold. Make a homogeneous mixture to improve hardness of ornament of gold. So, this one is also example. Similarly, alloys, all alloys, brass, German silver, bronze, stainless steel, nichrome, they all are examples of solid solution, while solute is also solid and solvent is also solid. So sometime in exam they will ask, a common example is given to you, as for example, in soda water, which type of solution and which one is solute and solid? Give answer. So this type question will ask from this table 2.1 given to you in your textbook. Thank you.